Hello everyone, welcome to part 3 of the video series on building an AI investing assistant. This video series is a journey of the design and development of an AI assistant that can perform financial analysis and answer questions about any public company. In previous videos, we demonstrated the assistant's current capabilities in handling complex questions and generating answers that were useful for informing investment decisions. We also discussed how transforming natural language into SQL database queries provided the assistant with up-to-date information, as well as reduced the likelihood of hallucinations or false answers. I've included links of the previous videos in the description. The system architecture is divided into 3 segments: data loading, natural language to SQL, and answer generation. In this video, we're going to focus on how the data loading segment works. The way this works is by using a financial API to get a company's data and then loading that data into a SQL database. When the user submits a stock symbol to the investment assistant, a request is sent to the financial API. The API responds with the full financial data set for that company, which is then loaded into the database. When this happens, the chat screen appears, indicating that the assistant is ready to answer questions and perform analysis on that company. The financial API that I'm using for this project is called fmpcloud.io. It does require a paid subscription and an API key, but it's very reasonably priced, particularly for our purposes here, which is proof of concept and building a prototype. With a subscription, you can access different types of data. This includes financial statement data like the income, balance sheet, and cash flow statement, financial ratios, earnings call transcripts, as well as insider trading and company profile data. For our purposes, we're going to focus on the financial statement data. To get the financial statement data, we would submit requests to these URLs, and we would add the company symbol and our API key as parameters. The way this works is we would send separate requests for each financial statement: the income statement, the balance sheet, and the cash flow statement. And then for each of these statements as well, we need to send a separate request for the annual financial results and the quarterly financial results. That's 6 requests in total to get a company's full historical financial data set. The data is returned in JSON format. This data is Apple's annual income statement. Each of these JSON objects is an income statement for a different period. And in the case of Apple, this goes all the way back to 1985. We can see that in each of these JSON objects, we have all of the typical income statement items like revenue, gross profit, EBITDA, and earnings per share. What we need to do next is make our request to the API and then take that data, combine it, and prepare it so that it can then be loaded into the database. I'm going to show how this looks in the code. There are 2 modules that deal with the data loading. The first module I'm going to look at is financials. This module is involved in requesting the data from the API and then preparing it so that it can be loaded into the database. The libraries that I'm using are URL-lib and pandas, as well as .env. URL-lib is to request the data from the API. We're going to convert that data into a pandas data frame. And .env is for loading the API key for FMP Cloud, which is stored in the .env file. There are 5 functions in the financials module. The first function, get single financial statement. This gets a single statement type for a single period. So we put in a symbol for the company that we're looking for, the statement type, which can be either income statement, balance sheet, cash flow statement, and the period, which is either the quarterly or the annual financial statement. Using these inputs and the API key, we'll create the URL to request the data from the API, and then load it into a pandas data frame. The next function, get period financial statements, uses the get single financial statement function in order to get all of the statements for a specific period type. So for example, you're getting the income, the balance sheet, and the cash flow statement for either the quarterly or the annual period type. The third function is called trailing 12 months. This creates a new period type for the trailing 12-month data. So for every quarterly period, we're able to get financial data over the previous 4 quarters. The financial adjustments function is where I create my own data columns. So there's certain financial items that I want to be able to adjust, like adjusted operating income or adjusted EBITDA. And then there's other financial items that I want to create, like funds from operation, free cash flow per share, or adjusted EBITDA margin. Finally, there's the single company full financials function. This combines the other functions so I can get all of the company's financial data for the quarterly, annual, and trailing 12-month period. Using the get period fin statements function, we get all of the company's financial data for the annual and quarterly periods, then calculate the trailing 12-month data, concatenate all of the financial statements, make our adjustments, and then return the full financial data set as a pandas data frame. I can show you how this looks using Microsoft as an example. We pull all of the company's data using the single company full financials function and see that Microsoft's full data set has 344 rows and 119 columns. And this is what the data set looks like as a CSV file. 119 columns, including revenue, expenses, cash flow, margins, balance sheet items, and data going all the way back to the 1980s for Microsoft. Now we need to load all of this data into the database, and for that we use the load database module. This module is pretty simple. It has two functions, DB connection and load data. I'm going to import the single company full financials function and then also use SQL Alchemy to connect to the database and load the data. And again, we use the .env library to load the environmental variables, which in this case are the database password and the database host IP. The DB connection function just connects to our database. I'm using a MySQL database on Google Cloud Platform, but theoretically any database would work as long as the columns are set up correctly. The load data function takes the company symbol as an input. It gets the company's full financial data set in a pandas data frame format using the single company full financials function. It connects to the database using the DB connection function and then loads the data frame directly into the database. And that's how the data loading component of this system works. By doing this, we're able to give our investment assistant access to up-to-date information on any public company, which is the first step in giving it the ability to provide accurate and useful answers to the user's questions. The next step is being able to access the database using natural language. And this will be the topic of our next video. Make sure you tune into this video and check out my channel if you're interested in more content on AI for finance. Thanks for watching.